Hello, everybody. Welcome to today's webinar on infrastructure as code on Azure. We've been looking forward to this webinar for a while. I know I have, and we're going to be discussing all things infrastructure as code on Azure. Let's jump in and do some housekeeping. Okay, so let's start. Let's start with some housekeeping. There will be no need to record today's session. What will happen is we'll email you around 24 hours after the session has started. Please use Zoom Q&A for your questions to myself and Mark Gray. Try and avoid using Zoom messaging as often the questions can get lost. For those on YouTube, please use YouTube and we'll try and get to your questions as well. We also have community Slack on octopus.com/Slack. You can put your questions into the webinar channel. So today I'm joined by Mark Gray, the Principal Project Program Manager at Microsoft on Azure. Let's bring Mark into it. Hey, Mark, how are you today?
Hey, everyone. I'm doing well.
Awesome.
How are you, Derek?
I'm good. I'm really excited about this one. I think this is going to have some really good stuff. So I think so. Mark, tell us a little bit tell us a little bit about what you do at Microsoft.
So I'm on a team at Microsoft that owns the Azure deployments. So my team, my broader team, owns essentially anything to do with any code that you would use to deploy Azure infrastructure. So if you're using PowerShell or the Azure CLI or ARM templates or Bicep or Terraform or Ansible or any of those things, that all comes to my team. So we work with, I work on Terraform mostly, but have been in the space forever. And I'm really looking forward to talking about infrastructure as code on Azure with you.
Awesome. Thank you very much for joining us. I think this is going to be this is going to have some really nice tips for everybody on today's webinar. Okay, so today's webinar is all about infrastructure as code on Azure. Obviously, Mark has kindly agreed today. It's almost like this has been planned, eh, Mark?
Yeah, right.
Yeah, so we're going to jump in. We're going to define what infrastructure as code is, what problems it solves, and then we're going to talk about specifically on Azure. And then we actually have 3 demos today. And then lastly, what we'll have is at the end of today's session, we'll have between 10 and 15 minutes for some live Q&A. Okay, so let's jump in and let's define infrastructure as code. I actually found this one on Microsoft, Mark. Do you want to jump in here?
Yeah, for sure. So I think infrastructure as code is a very interesting area. A lot of folks in the past have managed their infrastructure using what some folks refer to as ClickOps, if you will. So if they want to deploy a VM, they would open up a UI and get an experience where they can just add a bunch of values in for that thing and then hit go, and it's going to go deploy that VM. That is okay to understand kind of what you're doing and things like that, but when you get to the point where you want to actually do that at scale, so I don't want to deploy one VM, I want to deploy hundreds or thousands of VMs, you really need to have a way of documenting that. So you can say, this is the VM that I want to deploy, and I can deploy that not only at scale, but across environments. So when you're really using DevOps appropriately or maturely, you want to have test environments. So you want to deploy to a development environment, and then to a test environment, and then to the prod environment. And to do that in a way where you don't get completely different results in each of the different environments, you really need to have that deployment documented so that you can be consistent across those environments and get an expected result, if you will. So.
Nicely put there, Mark. That was very well done. What problems does it solve?
There are a whole bunch of different problems that it solves. If you think about where IAC came from in the application development world, you have always defined your applications in code, and then you had a process to deploy those applications where you can essentially make sure that this is the code that I've defined, and then I use that code to deploy my application. IAC essentially does that for infrastructure. So it allows you to prevent drift. So if you are configuring, well, you want to make sure that when you define something in infrastructure as code, if someone goes and makes a change behind the scenes, infrastructure as code will make sure through a pipeline that it'll pull it back to what your state is that you desired, essentially. So it gives you the ability to number one, see that drift, and number two, fix it. Either update the code so that it reflects what that drift should be, or actually change it back to what the code should be. So one of the areas that I think is really critical from the infrastructure as code perspective is when you're using the click ops mentality, when something breaks, the first thing that happens is leadership comes to you and says, what changed? And in the past, when you're using that mode, it would be 1, 2, 3 days worth of work to figure out what changed and what you need to change back and things like that. When you're using infrastructure as code and you're checking that in, you have version control and all of those kinds of things. Just go look at the last version and see what changed and roll that back if you need to. So it really shortens that recovery time and gives you visibility into what changed so you can fix it.
Nice. That's the thing. It's, I remember that. I've had that tap on the back of my shoulder. It generally adds a little bit of sweat to your day.
Yeah.
The thing I really love is it allows you to treat your infrastructure exactly like your application code.
Yeah.
I think that's for me is really, you use pull requests, you test it, right, and then you test it again, and with that as well, you've got idempotency as well, which is a core principle here. Idempotency is the property that a deployment command always sets the target environment into the same configuration. That's key, right? Like I remember, dev, test, pre-prod, etc., all very different from production. You definitely want to be as
Yeah.
production-like as you can get.
Yeah, for sure. And just from the perspective of making sure you have the same things across environments, no matter how good you are at ClickOps, if you will, if you're going through ClickOps, your end result is going to be different each time you do that. Where infrastructure as code, it's going to be exactly the same because it's defined in code. So.
Yeah. I think, do you want to say that it's a really good point there, right? Like, it's a bit like installing IIS. I remember, I come from an operations background. Installing IIS is super fun, right? After the 73rd time that week, it kind of loses its sheen a little bit. Like that, you can just, you can use infrastructure as code to do all that for you, which is really good. Okay, so let's jump into infrastructure as code on Azure. This does feel like a good one for you. I know you've touched on pretty much all the infrastructure as code there, and there are many. We won't be able to look at them all today, unfortunately, but I do have a few on the slide deck. Do you want to jump into this?
Yeah. So I think one of the things that is important to understand about infrastructure on code on Azure is Azure has some core infrastructure as code that it has released in the form of ARM templates. But Azure does not take the stance that ARM templates are the only way to deploy to Azure. We understand that customers have different needs and different preferences. So like I mentioned, our team owns all of that stuff, and we want to be sure that you have a great experience deploying to Azure no matter what IAC tool you decide to use, and then you can use it to deploy anything you need to Azure. So we want to make sure that you're successful, whichever IAC tool you choose to use, and that is we invest in all of these areas and more, be it all of these examples that we have up here are declarative. Whether you're using a declarative approach to deploying your infrastructure or you're more comfortable with imperative, using some AZCLI or PowerShell or something like that, all of that stuff is should be a great experience on Azure.
Awesome. Thank you so much, Mark. It is really cool, right? Like, I've been using ARM templates for a long time. Bicep is the new kid on the block. We'll jump into that a little bit later.
Yeah.
And then Terraform as well. So there's we do obviously there is Pulumi, but we don't have time for that today. We tried it unfortunately, but just there's too much in a single webinar. So what are ARM templates, Mark?
Yeah, so like I mentioned, or started to mention in the last slide, ARM templates are essentially the Azure kind of native way of defining infrastructure as code. So it's what Azure understands under the hood. And to really understand what ARM templates are, you kind of have to bump up a little bit and understand what ARM is. And just to touch on that real quickly, I'm not going to go into depth on what ARM is, but ARM is a single control plane for everything to do with Azure. So what that means is it provides a set of tools and services that are common to all services on Azure. So if you're going to deploy a VM or SQL or anything like that, they all go through ARM and give you things like Azure policy and RBAC, so permissioning and things like that, as well as scoping, tagging, all of that kind of stuff is common across all of the different services. And ARM templates are just one of those, or the deployment engine itself is one of those services within the control plane. And ARM templates are passed to the deployment engine to actually deploy those individual services themselves. So it is a way to deploy your infrastructure. There are a bunch of different parameters and values and all of that kind of stuff, but essentially it is a declarative way of stating what you want your infrastructure to look like on Azure. And there's flexibility in like passing parameters and values and things like that. So you can define an ARM template and be able to deploy that across different environments by changing the values of those variables and whatnot.
Awesome. Thank you very much for that. That was really insightful. So what do you think the benefits here are, Mark? And this does feel like a good one for you.
Yeah. So the benefits of ARM and ARM templates as a whole are, like I mentioned, they are native to Azure. So in order for a service to be published, ARM is part of that process, or ARM templates or ARM and ARM templates are part of that process. So when a service is released or updated or what have you, ARM automatically and ARM templates automatically support what is there. So it's really about being the native approach to how you deploy IAC in Azure. There's a whole bunch of other things to add to that, but like I mentioned, it is part of the control plane. So because it's part of the control plane, you get the benefits of all of those things that are part of the control plane are taken into account when you do a deployment. So if I do a deployment using ARM templates and there's a policy that says you can't deploy a VM or something like that, it will be actually, it will give you that information and feedback and validation essentially when you do that deployment. Where some of the other approaches where if you go through the APIs directly, you don't get that kind of integration with policy and those kinds of things. Go ahead.
Policy as code is really nice, right? Like I'm a huge fan of it. Like obviously I come from an operations background and security, and went and done this DevOps thing. I just love that you can really kind of define everything as code, like even all your policies as well. It's super powerful.
Yeah. And ARM templates are the format of ARM templates are JSON code, which can be complex at times, to say the least. But we do have integrations with VS Code and things like that to make the experience easier, so that customers can actually uh, create ARM templates easily and reliably, and much better experience, essentially.
Yeah, and I think as well is a lot of it's reusable, right? Like, one if you have a huge one, you can actually reuse parts of your ARM templates. Some really good stuff here, and also things like CI/CD integration. You can test it. I think like that is the infrastructure as code benefits apply to ARM, but with that, I'll be honest, like with ARM templates, super powerful. I don't know about you, but I quite often set it up manually that first time, right? Like, and then I know what I understand what I'm actually trying to automate. So I actually take that. And one of the things that I love actually about Azure is you can even deploy it and then get the ARM template from the deployed setup. Obviously, don't do that all the time, but definitely jump in and start writing and understanding ARM.
Yeah, for sure. That is a great way to get started with infrastructure as code and ARM templates. Is actually doing the ClickOps approach to start,
Yeah.
and then actually exporting that, and then using that ARM template to actually uh, deploy changes and things like that going forward. So.
Yeah. No, that's the thing. I think it is a really good way to get started as well. And one of the things is, and there are tools out there that will help you. It's almost as if this was planned, Mark. So at this point, what I'm going to do is I'm actually going to show how you can do ARM deployments with Octopus Deploy. So in this example, what we have is Octopus. So this is just so you can actually see this in webinar.octopus.app. This is fully open. You can get browse as a guest. So what we've got here is our three examples. I think there's a bit of a giveaway here, in that we are going to be using ARM templates, Bicep, and Terraform. So runbooks are a way for us to deploy our infrastructure as code, as Mark was saying. In this instance, let's jump in. We'll see here. I have tested this a few times, Mark, thankfully. So we'll jump in and have a little look at this. So actually, what we've got here is a runbook for the Create ARM infrastructure. So let's jump in and have a quick look at this. And what we're going to do is I'm going to just run it because it's going to be that quick that by the time I've ran it, I'll have explained it all. So what this is doing is this is going to run through, and this is going to run through a few steps. Let's jump into GitHub. Let's actually have a quick look at the code. So what we've got here is this is a repository. I'm just using GitHub code spaces here. And what we'll do is we'll jump into the ARM template. So in this, I do have the code. So what I've got here is a PowerShell script. I'm actually creating the Azure resource group because in all of my demos today, I'm going to deploy three things. I'm going to deploy an Azure App Service plan after I've deployed a resource group, and then lastly, the app service. So all three demos today will deploy the same thing. And what I want to do is just show you how different they look. So what you've got here is you've got your resource group. So the reason we actually use PowerShell is you have to create this from a resource group to then create your resource group to store your infrastructure as code. So what we've got here is we're using some Octopus variables, and here we're just specifying these at the top. And what we're doing is we're just checking to see if the resource group actually exists. If not, it goes ahead using PowerShell and creates it. So this is ARM. As you can see at the top, you've got your schema, you're defining your versions, all your parameters. And then down here, this is where things start getting a little bit interesting. You've got your resources, so obviously you're specifying things like name, location, your SKU, etc. In this instance, I'm using this alongside Octopus today to do this. So this is the app service plan. And then from here, we then have the app service. You'll see here that it contains the parameters. So obviously, you've got your name, your location, your hosting plan name. And then, again, you'll have your resources. We're specifying the name, the SKU, the properties, etc. And then what we've got down here is lastly, this outside of ARM, and this is more for Octopus because you've created it and you've created it as part of a runbook, you actually also have to tell Octopus that the web app has been created. So in this, I'm using PowerShell again, and then specifying things like base URL, space ID. This is using some Octopus library variable sets, such as a global base URL. You've got your API key, your space ID. I'm using anything that starts Octopus. These are built-in variables. I love built-in variables. The main reason I like them is that I can actually do a lot of my heavy lifting, my naming conventions actually using this. So what you'll find here in today's demo, I'm actually using a combination of Octopus variables. The space ID, so what I'm actually going to do is create the resource group using the space ID with the project name and then environment actually appended to it. So what it does, and I don't know about you, Mark, but sometimes when you're working at scale, it's really hard to find what you've actually deployed, right? Like, it's fine when you're starting off and you've got a single subscription, but once you've got thousands of servers distributed across the world, that gets pretty complicated, right?
Yeah, for sure.
Yeah. So,
Yeah.
okay, so what we've got here is this is the PowerShell to do this. And then lastly, I actually also have the destroy infrastructure. And I think one of the things I love about Azure is one of my favorite things is Azure resource groups. I think the reason I love Azure resource groups is a logical container. So when whatever I create, whatever I test, and inevitably sometimes it will fail, I can just delete the resource group. In this instance here, we're using PowerShell to delete the resource group and then deregister the app. So there is some PowerShell mixed in here that will really help you out. So there we go. So what we've got is, let's jump into the task log. There we go. So we've got our Azure IAC resource group name. So there we go. So as you can see, Azure-IAC, you notice there that we're using the space name. And then ARM template is the name of the project. And then lastly, test. When I deployed this, it was using test. So no matter what I do, I actually push it through. And this will work for dev, test, pre-prod, whatever environment. All you have to do is make sure that you use certain things in Octopus with your Octopus variables. And as you can see here, we're creating the app service plan. App service plans are something that it's a container for your app service. So as you can see here, we've got this. We'll come down, and then lastly, we do have the create Azure web app. So this is also this has all been done. So we should see that if we come into infrastructure, we have a test environment, and then there we go. So let's just have a look. So there's our a freshly created Azure web app. We don't show resource groups or the app service plan, but as you can see here, this is using our test account, and then this is using the Azure-IAC ARM template-test. You can see this in webinar.octopus.app, and you can also come along to github.com/Octopus Deploy Community. Also, the Azure Quick Start template repository on GitHub is a great resource to get started with more complex examples. Is there any resources that you would share with the viewers today, Mark?
From the perspective of what kind of resources?
Just getting started. Any resources that getting started with Azure?
Yeah, I mean, we have the ARM deployment documentation on Azure, which has a bunch of good information about getting started. There are quick starts on GitHub. So there are hundreds of different quick start templates. So you can actually use those to get started. So you can look through, and if you're interested in deploying networks of any kind, you can actually find examples on there and use that as a starting point for your ARM deployment. And additionally, on docs.microsoft.com, if you are interested, whatever service you're interested in, if you go to resources for that service, you'll be able to find ARM template examples in there as well on how to actually deploy that service.
Awesome. Thank you so much. And also, one of the things I find sometimes that happens, Mark, is people are great at creating infrastructure, but less so at tidying it up afters. I feel that that's a very important, and that's for all of the infrastructure as code languages and examples that we have today. So whatever you do to create your infrastructure, make sure that you're a little hygienic and you clean up after yourself, and you can tear that down. That's always a good time.
Yep.
Okay, so we now have a little bit about Bicep.
Yeah. So, like I mentioned, ARM templates are native to Azure. They are JSON, so they can be a little bit complex at times. So Bicep is a language that has been written to make it easier to define what resources to deploy in Azure. So it is a domain-specific language that you use to actually define the resources that you want in the state that you want them to be in. So it is declarative, and it is an abstraction over ARM templates. So you define Bicep, and when you build Bicep, it will actually output an ARM template and then deploy that ARM template to the deployment engine in ARM. So if you're going to deploy to Azure and want to use the native language for Azure, Biceps are the way to go, or Bicep is the way to go, just because it is easier to understand when you define a configuration in Bicep and you pass it over to your colleague that hasn't looked at it before. They'll be able to understand exactly what the desired state is and things like that. Just pass the ARM template over. It might take a few minutes or a while for customers actually understand what's happening there. So it really is a higher level abstraction that makes it easier to define and understand your infrastructure as code.
Nice. I think there as well. I'll be honest, like ARM is super powerful. I've found at times it can be quite frustrating. And I have to say, when I've jumped into Bicep, I love it. It's just, I will show you a little bit of an example later on, and I'll compare the two examples. When you look at it's what I would say most of the time it's at least half, if not, looking at roughly a third of the size. So, Mark, what do you think are the main benefits?
The big benefit is easier syntax, not only to write, but to understand. It is native to Azure, so just like ARM templates, there is day zero support. So as soon as a service comes out, be it in private preview or GA or what have you, Bicep is available to actually manage and configure and define those services. It supports, and by day zero, it not only supports all of the resources and types and things like that, but it supports all of the APIs for all of those services. So if for some reason there is an API, there's a bug in a newer version of the API, you can always go back to the older version of an older version of the API. So it really gives you a ton of flexibility on being able to manage Azure and do it in a way that is very understandable. So.
Nice. Okay, so I am going to jump over and do a demo. At this point, I am going to have to unshare my screen. The main reason is Bicep using code spaces isn't fully supported yet, so just something to be aware. I apologise for my face. There's nothing I can do about that now. But what we have is, let's just jump over. I'm just going to switch over to Bicep. Let's see this. So there we go. Select allow. There we go. So let's get this in. So what we've got here is this is your bicep file. So you're specifying your parameters, things like so obviously you get your web app name, SKU again, much easier to understand. Find you're defining everything up front, and then at this point you've got 38 lines of code.
One of the simple things to point out there that is not available in ARM templates is the green text on the right of your parameters there, the comments that you're putting in there,
Yes.
something as simple as adding comments was not doable when you're using JSON. So it makes being able to document your code with Bicep um, very, very simple and straightforward.
Definitely. Like, do you want to see when you said that? I almost like I have a terrible memory, and you know what it's like. Sometimes it can be months between me doing something. So the just leaving comments, it's kind of like paying it forward to yourself and your colleagues,
Yeah, for
which
sure.
is really really nice. But this is the thing, and if you are looking at this thinking, "Hey, I've seen this before," I won't lie. This is mostly copied and pasted straight off the Microsoft docs. So that's just, and you'll notice the next one, which is Terraform, will look very similar as well. So let's do a quick comparison. So you can see here you've got the bicep file. Let's just jump in and do a quick comparison alongside. So there we go. So you can see there, just to, and one thing is this is there's four. You know, obviously there's a single line there that we're doing in this instance as well. You know, it's went to what 38 lines. You've got comments, etc. And, you know, with this is much harder to understand, and there's no comments. So that does. I just really like this, and actually play. I'll be honest. I've been playing with Bicep for the last couple of months, so I've just generally found it much easier, much more fun, and less frustrating. So unfortunately, at this point, I am going to switch back, and then let's go back to my.
So while you're switching, what we've actually found is that there have been fewer errors. So customers that are using Bicep to deploy their infrastructure, there are actually fewer errors. So from a user perspective, deploying ARM templates versus Bicep, you actually have a better chance of succeeding using Bicep, even though ARM templates under the hood are used to do the same deployment. So
Yeah, it's to be honest, I've just found that it's actually been really nice. Like one of the things, like with the learning, I found that kind of learning curve was quite steep. You know, well worth it. But like this, what I was able to do was copy and paste something off. I understood it, and that's not. I'm not a developer. So like straight away, it was just this made sense, right? Like you
yeah,
know, obviously from here we've got this, and it works really well.
yeah.
Okay, so let's jump into Bicep. So again, what we've done here is we aren't doing anything with deployments. In this instance, it is just a runbook. Again, I have been playing about and making sure this works. But the good thing is, and this never happens to me, Mark, if I'm being honest, it's all green all of the time. That does not happen. Normally green after about 27 attempts is more of a generally how it works for Derek.
Yeah,
So
it turns out it's a
again,
little easier to write Bicep than it is to write raw JSON. So
oh, Jason is super powerful, but
yeah,
I think we've all been there, let's be honest. So what I'm now going to do, let's jump in. We're going to create the bicep infrastructure. So again, we've got two steps. I am using the same step from the last time. Again, similar. I need the resource group to exist. So we've got here, we've named it the resource group. This is bound using Azure account. So again, I map, I actually scope um, test, for instance, to a specific account. You can. This is very very powerful. And then again, we've got our PowerShell. Let's be honest, though, that's not the most interesting thing. One thing just to be upfront is Bicep does not have a built-in step with Octopus, but the benefit is ultimately it outputs JSON, right? Or ARM template. So what we're actually doing is we're extracting it and then deploying it. So in this instance, we're using the run an Azure script step inside of Octopus deploy. And then at this point, what I'm effectively doing is extracting the package. I'm changing into the file path. And then at this point, I'm actually putting the deployment name in. And then from here, I'm using AZ deployment group create resource group. And then from there, we're specifying the template file, which will go ahead and deploy that on template. So at this point, let's run and see. I'm hoping this it's still green. Um, I was a little bit suspicious when it went green first time. I was like, this ain't nothing. This can't be this easy, right? Okay. So at this point, Mark, what it's going to do is going to create that resource group using the PowerShell script that we've got. It's going to grab that package. That's one of the things here is I actually have. So in Octopus, you can come into library. And again, this is one of the things that we were chatting about earlier on is Bicep. We actually upload, so you treat it exactly like your application code. So if you're deploying, say, zip files or NuGet packages, you can treat and actually package up your infrastructure, version control it, and treat it exactly like your application code, which is super powerful. Okay, so at this point, let's jump back over. Hopefully, we've got some infrastructure in place. There we go. We've just got this. So at this point, the resource group. So you've got Azure IAC Bicep test RG, which is our resource group. Again, I make heavy usage of built-in Octopus variables, mostly because I find it really easy. And to be honest, I've been there, and when you're trying to find what's changed, and it's it's days of work, like you were chatting about earlier on.
Yeah.
So let's see. There we go. So what we can see is we can actually see that the resource group exists. Obviously, as you can see just now, there is no app service. The main reason for that is still being created. So at this point, it's grabbing the package. There we go. It's extracting it, and then at this point, it's going to run the Bicep file, which is then going to create all the infrastructure in the resource group. So, Mark, which is your favorite? I've got to ask this up front.
Which
approach?
Which
Yes.
what?
Which IAC language is your favorite?
I to be honest, like I mentioned in the beginning, I focus on Terraform, so I'm a little bit biased there. But I work with all of them, and all of them have their pluses and minuses. We actually put an article together and have posted it to the Terraform Dev Hub that actually does a comparison of Bicep and Terraform, because we get a lot of questions about when should I use Bicep or when should I use Terraform or what have you. And instead of having the age-old answer of it depends, we wanted to kind of give more context for that. So we've kind of put together a pretty thorough article on kind of some of the benefits that exist for Azure and some of them that, some that exist for Bicep and others for Terraform. So I definitely recommend taking a look at that.
Yeah, no, I think I think that's the thing, right? Really, it's about taking the right tool that works for you, and then using that for Azure.
Yeah, for sure.
Awesome, awesome. So this has been running for 2.5 minutes. Let's jump on over, and then we'll just let's see. So we've got our overview, and then there we go. So we can actually start to see that our app service plan has been created. We actually have our app service plan as well. So that's pretty much good. We have deployed it. There we go. So it's just we'll just be finishing that up. If you can actually see in Azure, if you come into deployments, you should actually see this happening as well. There we go. So yeah, you can see the overview. So it's just that the web which has just been created as well, and that I'm sure that'll finish up as well. Okay. There we go. So let's jump on over. I think we've shown exactly how that works. That's really good. You can check that out on webinar.octopus.app, and that's in the Azure-IAC app, and then that's under the Bicep project. Okay, so at this point, we're going to jump into Terraform. So what is Terraform? This definitely feels like it's a slide for you, Mark. Although this does feel like a recurring theme.
Yeah. So Terraform is an open source configuration tool. It is owned by HashiCorp, and the whole mantra of HashiCorp in general is that they want to provide infrastructure as code tooling or infrastructure tooling that works no matter where your infrastructure is, be it on Azure or AWS or Google. Or what have you. They want all of their tools to work across all of those. And Terraform is the IAC tool. So how you actually define and deploy your infrastructure using HashiCorp's tool set. We have been working with HashiCorp for a long time to make sure that we have great coverage of Azure. We have a number of different providers. So the way that Terraform allows you to configure multiple infrastructure sources, like different clouds and things like that, is by having a provider model. So each cloud will have one or more providers, and that provider knows how to connect to that cloud and how to actually configure the services and things like that in that cloud. So we work with HashiCorp. So we have engineers at Microsoft and at HashiCorp that are dedicated to adding coverage to the Azure providers, and so that you can actually configure anything in there. It is targeted at the GA services. So Terraform uses state. So state is a way of tracking the current state across all of your infrastructures, so that Terraform knows what needs to be changed. So it actually uses state and then your configuration, and will determine the delta, and then only make changes to things that have changed. So I could go on and on about Terraform, but it is essentially a third-party tool for provisioning, and it's popular among a lot of Azure customers. So we found it important to make sure that we invest in it and make sure that those customers can be successful to deploy to Azure using it.
Nice.
Go ahead.
No, I think the key thing here really is just it's a state file, right? Without the state, it's not going to you're not going to have a good day. But I love that because ultimately, it's all that it goes back to idempotent. If you update that you want an additional web app and then deploy your full Terraform, it's only going to pick up that new web app.
Yeah, exactly.
So
that is one of the most powerful things about Terraform and the state file, how it actually builds that delta and says, I know you have 1,000 things that you are managing in your infrastructure, but this one change, so I'm only going to send one API call to make a change to that thing.
yeah. And that's the thing. I think that's what the benefit of the state. And obviously, you can use Azure Storage. I know that there's some Terraform Cloud as well, which you can help as well. So at this point, let's jump in and do a demo. Okay, so let's jump back. So we'll go into and have a look at the Terraform. So we've got here single file, just .tf, which is your Terraform extension. There we go. So we're actually mentioning straight up, like you said, Mark, about Azure RM, which is Resource Manager. We're specifying the version. We've got the backend, which is we're using. We're actually using some Octopus variables here. I have already provisioned the Azure storage account, mostly because that does take a little bit more time, and I'm conscious of the time already. So you've got your provider, you're specifying you're in here again. You'll notice, Mark, this is copied and pasted mostly directly off the example on Microsoft Docs. Okay, so let's jump in, and in this one's a little bit different, Mark, mostly because of the way with the state file. So again, we've destroyed everything. One thing I do have, again, you can come and see this in webinar.octopus.app, is I do have the create resources. In this instance, this is just we're just provisioning a storage account. We provision a different storage account depending on the environment as well, so that's something to think about. But as you've got here is we've just got some Azure PowerShell, which we're going. I won't lie, there's it's a bit more than I'd like to show, but with this, we're creating the storage account and making sure that that Terraform has access to it. So let's jump in. I'm just going to create the Terraform infrastructure. So again, we're taking the similar approach here. We are just doing we're doing with Terraform, we are provisioning a Azure App Service, the resource group, and the Azure Web App. The difference with this is Terraform works in a slightly different, approach. You've got Terraform in it, which is your initialization. So from there, and then after that, you have your Terraform apply. Do you want to jump in and discuss that a little bit, Mark?
Yeah, sure. So So the reason Terraform init exists is the Terraform executable itself will look at your configuration and see what resources and providers are required to actually run the configuration, or modules for that matter. And it will actually download all of those required properties and things like that. I'm sorry, providers and modules and everything, and then do some high-level validation of your configuration before you get started. So it'll essentially do the groundwork of making sure you have all of the components for that configuration to be successful before you actually do a plan and apply. And the plan is actually another powerful feature of Terraform, where it will actually look at your current state and then look at your configuration and tell you what needs to be changed or added or deleted to get you to the desired state that's defined in the configuration.
Awesome.
And it actually builds that Delta file, essentially, that you then can deploy from there.
Awesome. So whilst that's happening, what we've done is we went ahead and done the apply. So let's just jump in. We'll have a little look what we've got now. So in this step, what I've actually done is I've actually you're spot on there with the plan apply it. In this instance, what I've done is I've used a manual intervention step. A manual intervention step is exactly that. It's effectively just a way for you to check something before it's about to hit. So in this instance, I've done the plan, which is a built-in step with Octopus. And then what I've actually done is, you'll notice here, let's just have a quick look. So what I've done is I've used that and piped the plan into the comment for this. So what we've got here is, this is the full file. So it's used to selected providers. At this point, it's telling us that the following actions, so obviously Azure RM App Service Web App will be applied. I don't want to spend too much. Please do check that. But as you can see here, is plan. You've got 4 things to deploy, which is great. There we go. So at this point, I'm just going to say, Mark said it's okay to deploy.
That's good. Pass the blame.
Yeah. That's I get. Okay. I can see you. Yeah. Okay. Yeah. Definitely. So at this point now, what it's going to do is, it's going to go through and it's then going to actually use Terraform apply. At this point, what we should start seeing is we should see 4 resources at this. So let's just see. We're just running through this, and what we're going to do is grab the same package, and then at this point, it's uploading the Terraform, and then it's running through the apply. So let's, as you can see here, there we go. We've got it's all running through. So yeah, so at this point, what's going to happen is, let's jump over to Azure. Let's see the resource groups. Let's see. We can see here we've got Azure-IAC Terraform Test Resource Group. That sounds like our resource group. We want to come into deployments, and then there we go. So at this point, what this should be doing is it should be activating. There we go. So you've got. Let's have a look at the log file. So what we're doing is we're going through creating app service. We are also it says 4 in this instance. The 4th is actually using a random integer to apply that to the web app so that it's uniquely identifiable. So there we go. We've got everything here, and then what it's done is it's going through everything. It's configuring, and then what we should see is we should be applying. So there we go. So obviously there's the app service. This is still creating. Let's see. We should see our deployment. One moment.
So Terraform is not going to show up in the deployment. You'll just see the resources. So that is one of the differences with Terraform and Bicep and ARM templates, is that deployment is the deployment engine. So you're deploying an ARM template, and Terraform actually deploys using the raw APIs
Right.
in Azure. So you actually won't see that deployment filled out for Terraform itself.
Nicely put. I did not know that. That is something I've only just found out. That's really cool. What we do actually have here as well, just one thing, is this is our state file. So that's one of the things. So you can use Azure storage for your state as well. And what this will actually do is it will just, when you're using Terraform, It'll actually everything go into a .terraform file, and you'll see all the information there. So please do feel free to clone this repository down and have a little play. This will definitely help you out. Okay, so there we go. So it's going ahead. It's got the app service there. That's just basically now waiting to deploy. Just obviously taking a wee while. And then yeah, it'll go. So it'll go through. It'll create the random integer. It'll create the Azure App Service, the resource group, and that app service plan, which we can see. Just let's see. We'll just maybe just zoom out a little bit. It's always I always find apologies if you can't see my screen. It's a fine line between being able to see everything and making sure that you can still see the text on today's webinar. There we go. So there we go. It's went through. There's the file. Let's just go down to the bottom. There we go. So at this point, it's went ahead, created four apps, 4 bits of infrastructure using Terraform. Okay, so that's everything done now. Let's at this point, we're going to jump in and talk a little bit about why you would use Octopus Runbooks with it, the infrastructure as code. I think really the key thing here is that Octopus Runbook is literally built for infrastructure as code. It's exactly what it's for. It's built for those routine emergency tasks as well. But hopefully you've enjoyed what you're seeing today. I am a huge fan of Runbooks. I think coming from operations before moving into DevOps about 10 years ago. But yeah, with Runbooks, has a range of built-in things like variables as well, which you can use as part of your naming convention. I'm a huge fan of that approach. I think it just kind of de-risks things and it gives you that accountability. And with that, there's a lot of really good stuff here. I'm a huge fan as well of actually centralizing the deployment of infrastructure as code. I don't know about you, Mark, but the idea anyone anywhere using any computer can deploy something that's local to their machine gives me a lot of concern. So yeah,
one of the things that I think is really powerful about Octopus Runbooks and similar things is how it allows you to speed up in a safe way your deployments and things like that. So it's built for infrastructure as code. But deploying something simple allows you to iterate more quickly and actually build up and be confident about actually making deployments and knowing that the end result is going to be what you expect.
Yeah, definitely. I think the key thing as well for me is like that's it. It's very seldom do I actually get to a point where one of the key use cases I use is deploying everything to test, but using dynamic infrastructure. So creating all the infrastructure, deploying your code, testing it, and then tearing it all down again. And one of the things I found is it can reduce your testing cost by 95% if it's only ever online for as long as you need it. If you scale that across all your environments, there's a lot of savings there, right?
Yeah. Yeah, and I think that's valuable even if you manually test. I mean, if you deploy your infrastructure to test and do some manual tests and then tear it down, before you get to the sophisticated level of actually running tests and stuff like that, it's even a huge value at that point.
Yeah, definitely. Okay, so let's see if there's any questions. Okay, so Mark will answer the Azure questions and I'll be answering the Octopus questions with this, which I think we've already jumped into this. David is asking which is your preferred method. I think it's Terraform, right? Which I love as well. Really good one. So what's your thoughts on Pulumi? Obviously, Rebecca is asking, obviously we didn't have time to do it. What's your thoughts on Pulumi? Can you give us that in a 30-second nutshell?
Pulumi is, I think their strength is that it's infrastructure as code, but unlike Bicep or ARM templates or Terraform, you don't have to learn a new language. Even though Terraform and Bicep, in my opinion, are really easy to learn. If you're familiar with something like Python or something like that, you can use that language to actually deploy your infrastructure. And I think the sweet spot for Pulumi is When an app developer actually needs to own their own infrastructure deployment as well, they can use the same code that they use to deploy their application to actually deploy their infrastructure. So not only use IAC in a way that is aligned with their application code, but use the exact same language to deploy their infrastructure and their application, which is pretty cool.
Nice, nice. So, if from a performance perspective, which of the infrastructure as code languages, if you wanted to deploy something at the absolute fastest that you could do it, which approach would you recommend?
It really depends on what you mean by fastest. I mean, if you're talking about writing the code and things like that, definitely something like Terraform or Bicep, because it's just easier to write and quicker to actually do the authoring of those configurations. And easier to troubleshoot. So if you come back to that code 6 months down the road, not only with the comments, but just looking at the code, you can actually understand it and make changes to it. So from the authoring perspective, using one of those declarative languages that you're familiar with is going to be faster. And as far as actually the deployment end of the speed, I'm not sure if there's much of a difference. Yeah, it really depends. I've heard both sides from customers that some customers say Terraform is faster, other customers say templates are faster. So it really just depends on your use case. They are being provisioned in very different ways, where Terraform is deploying using the ARM APIs, and ARM templates and Bicep are being deployed using the deployment engine in ARM itself. So you do get some optimizations and stuff like that if you're using ARM templates. That being said, Terraform does optimizations in and of itself. So if you write a configuration and make some changes to that configuration, it's only going to call the APIs that are required to actually make those changes. It's not going to be calling every single API that you have in your configuration defined, essentially. So it really is something that you would have to play around with in your typical use cases to determine which one actually is faster from a kind of an actual deployment perspective.
Awesome, awesome. Thank you so much, Mark. Unfortunately, we are almost out of time. I won't be able to get to the rest of the questions, but please do reach out to us on email if you need. We can always help out there. So, Mark, thank you so much. That was awesome. I've really enjoyed this session with you today.
Thank you, Derek.
Awesome. So, if you want to become an Octopus customer, please do check out. You can get in touch with us at customersuccess@octopus.com. We do offer free consultancy to all of our customers, so you can reach out to our customer solutions team at advice@octopus.com. And then lastly, please do stick a thumbs up and a subscribe on our YouTube channel. We've got a lot of really good stuff there. This webinar will be up there in the next day or two. And thank you so much for attending, everyone. We really enjoyed today's session. We do have another session with Thomas and Sarah Lean. They're going to be talking about Azure Arc and Octopus Deploy. Thank you, everyone, for attending. Mark, you've been a pleasure, and I'll chat to you all soon. Thanks, and good day.